We can also apply the intermediate value theorem to find solutions to equations that don't look easy at all. For example, this one, x squared equals cosine of x. Let us show that it has a solution. If not with this theorem, it can be very difficult to know if this has or not a solution, and even more complicated to approximate it. But you see, to apply the theorem, you just need to have a function, f of x, which in this case, you can take x squared minus cosine of x. This one actually happens to be continuous for all values of x because the two functions, x squared and the cosine, are standard functions. Okay, when you say it's continuous, you have to give a reason for it. The reason is that they are standard functions, they are polynomials, etc. Okay. Now, in this case, we want f of x. The equation is f of x equal 0. Okay, so then our number n in the theorem is 0. So we only need to find now, actually I could write here, instead of x, I can write c, so that it's clear what we are doing, just as in the statement of the statement of the theorem. Now I need my a and b, right? This we learned that we just find them by inspection. So let me try. As I told you, it's better to try with values that are easy. So I can try 0. This is 0 minus the cosine of 0. This is -1. So it's less than 0. Okay, we always need to compare with the value of n. And then, well, I have a negative value. Now what I need to find is something positive, so that it's on the other side of n. We can try with something large. Let's try f of 10. See what happens. Why did I pick 10? Well, because if I pick 10, I have 10 squared minus cosine of 10. And you may say, well, and what is cosine of 10? And I'm like, well, I don't care, because this is 100 minus cosine of 10. And the cosine of 10 at the largest is going to be equal to 1. So this thing over here, 100 minus cosine of 10, is going to be larger than 99. Okay, so this is positive. Well, I can say this is bigger or equal than 99, and then it's positive. Okay, this will be somewhere between 99 and 101, because depending on the value of the cosine of 10. You can also punch it on the calculator, it will tell you exactly, but what I'm showing you here is that you don't need a calculator for something like this. All right, so we have f of 0, which is less than 0, less than f of 10. So this is my f of a, this is n, this is f of b in the theorem. The function is continuous. We already checked that. So the intermediate value theorem says there is a number c in the interval 0, 10 such that f of z equals 0. That means c squared equals the cosine of c. Okay. So there is one root in this interval 0, 10, which is already very good, but you could want to a better approximation. Okay, maybe this is not enough. So I leave it for you to do. Refine the interval. Okay, make it smaller. See what happens. So here, well, we have already seen at 0, f of 0 is negative. At 10, f of 10 is positive. So try with 5. Okay, and then it may be positive, it may be negative. So if it's positive, let's use some colors here. If it's positive, then you try to find your C on the left. Okay, it will be somewhere on the left of 5. Because you see f of 0 is negative, then you found something positive that is b equal 5. But if it comes out negative, then you know for sure that your value c was lying on the right of 5. Okay, so those are the two possibilities. You figure out which is which. Then you can keep refining, splitting the interval in halves until you are satisfied with the result.